This is the quiz review for geometric proofs, and it's also going to have linear pair on it, vertical angles, complementary angles, and a lot more definitions that you learned will be on your quiz. Number 2, angle QPS is congruent to angle TPR. Well, that was given to us, so that's our reason. From 1 to 2, the congruent symbol has changed into an equal sign. And the definition of congruent angles says that angles that are congruent have equal measures. So anytime you change from a congruent symbol to an equal sign, or down here an equal symbol to a congruent sign, it's the definition of congruent angles. Measure of angle QPS, so Q to P to S, is equal to QPR, and that's this angle right here, QPR, plus RPS, which is this angle right here. So what it's doing is it's showing us that the big angle QPS is equal to the two small angles that make it up. And that's going to be the same thing with TPR. You have large angle TPR made up of TPS and RPS. And that's the angle addition postulate. That says that the two small angles added together will equal the big angle that it makes up. The next property always follows angle addition. What they do is they say that since QPS is equal to QPR and RPS, and TPR is equal to TPS and RPS, that we can take these two sets of angles and set them equal to each other. That property, which will always follow the angle addition postulate, is substitution. Because what you're basically doing is you're taking this QPS and substituting in QPR RPS. That's how you wind up with this. And you're taking this TPR and you're substituting in TPS and RPS, which is this right here. From step 4 to step 5, QPR stays the same, RPS is gone. TPS stays the same, RPS is gone. Well, the property that allows us to subtract the same thing from both sides of an equation is the subtraction property. And then finally, the equal sign changes to a congruent symbol. That's the same thing as when a congruent symbol changes to an equal sign. That's the definition of congruent angles, which says that angles with equal measure are congruent. Let's take a look at number 4. First it says to find the measure of each numbered angle, and then name the theorem that justifies. So we look at angle 11 and angle 13 and see if we can identify the relationship. 11 and 13. Here's 11. Here's 13. And you see that they are adjacent angles that sit on a straight line. Their base is made up of a straight line. They form half a circle. This relationship is called a linear pair. And the linear pair theorem says that two angles that form a linear pair are supplementary, or they equal 180 degrees. So I'm going to take that concept and apply it algebraically. These two angles, measure of angle 11 plus the measure of angle 13, when I add them together, should equal 180 degrees. So angle 11 is 11x plus angle 13, which is 10x plus 12. And they're going to equal 180. I would first combine my like terms, so I have 21x plus 12 equals 180. I would subtract 12 from both sides. So I get 21x equals 168. And I would divide both sides by 21. So I get x equals 8. I'm not finished there. It didn't ask me for the value of x. It asked me for each numbered angle. So the measure of angle 11 would equal 11 times 8, which is 88 degrees. The measure of angle 13 would equal 10 times 8 plus 12, which is 80 plus 12, which is 92. And that's also how we verify that we solved correctly, because we said that these should equal 180 degrees when we add them together. So I would add 88 and 92, and you would see that they equal 180 degrees. So I know I did it correctly. Okay, number 6. I want to name the property that justifies each statement. This one's a little bit hard to see, but what's happening here is xy plus 20 equals yw, and xy plus 20 also equals dt. So I can replace this xy plus 20 here with what it says xy plus 20 equals, which is yw. So I can take this xy plus 20 and replace it with yw. That's how I end up with yw equals dt here. So what I've done is I've replaced xy plus w with a yw, or xy plus 20 with yw, and that's substitution. Number 8, you have a set of parentheses, so that's usually our indicator that we're going to distribute the 2 to the x, and we get 2x. 2 to the negative 3 halves, and we get negative 3. That's distributive property. Number 10, this is your line of symmetry here, where if I folded along the then, LM would be on top of LM and JK would be on top of JK. That's your symmetric property. And then number 12, they give you two sets of segments that are equal to each other, and then in the final line I take GH and I add it to EF. I take VW and I add it to TW or TU. So that's the addition property. It says you can add the same thing to both sides of an equation. And then finally, number 14, we start with our given. When a congruent symbol changes to an equal symbol, it's definition of congruent segments. It's the same thing as definition of congruent angles, except we're not dealing with angles, we're dealing with segments, as denoted by the segment bar and the fact that we use 2 letters. Okay, number 3, from 2 to 3, we take AD and CE and we add to it DB and EB. So we're adding the same thing to both sides of an equation, which is your addition property. From here to here, we have no real connection, so we look at this statement alone, and it's giving us segment AB, which is equal to AD plus DB, and that's your segment addition postulate. And what always follows segment addition, same thing that always follows angle addition, is going to be substitution, and that's when you take 2 terms from the previous and combine them to be equal to each other. That's your substitution property, and it will always follow segment addition. And then finally, an equal symbol turning into a congruent sign. That's your definition of congruent, and because we're talking about segments, we write segments.